demonstration, we are going to show how to import laser vibrometer data in VMAP. This set of laser vibrometer data is acquired using Polytech's hardware, and we will see how we can import these files and do post-processing in VMAP. So there are different file types that are available in Polytech. So the most common extensions that are used are PVD and SVD. So there are several examples here. I'm going to demonstrate the import feature and analysis using one of these examples. This is a really large data set, and we noticed that it was imported in a flash of a second. And as I just mentioned, there are several points in this model, and also the bandwidth of the acquisition was quite large, up to 20 kilohertz. So here let us look at various parameters that are available: FRF amplitude and phase, which is what we are mostly interested in. And there are several nodes. Let me just compress this and open. Node 1 all the way up to node 265. So just for clarity, if I want to just look at one of the nodes, let me just pick this: 9, 3, 4, 265, and so on. Now we have already done some analysis using this data, which is why we see this listed here. And also VMAP's mode indicator function, by just when the data is presented, has done an analysis and identified all these modes. In addition, if I want to add this mode, for example, I can do that just by doing an add peak frequency, and we would see that it has got added to this stack here. So what are the different analyses that we can do with this laser vibrometer data in VMAP? For example, we can do 3 different curve fitting on this data. So let me show one of these, say the rational fraction polynomial fitting. So I would like to fit a model and extract the damping and resonant frequencies for this particular frequency. So let me zoom into this and select the band of data which I would use for curve fitting. You can adjust this in a very, very fine way. And we say fit curve. That was really quick, given that there are 265 nodes and 20 kilohertz of data, FRF amplitude and curve fit amplitude. You can overlap these graphs and say I want to see only one of them. It's a perfect fit if you want to look at it qualitatively. That's node 1, node 2, node 9, 265, and so on. I'll bring up all the nodes. Most important thing when we are designing structures is understanding the damping characteristics, which we can get using these various curve fitting routines which are available in VMAP. So for all the point FRFs, 265 FRFs that are presented, we have identified the resonant mode and also the Q factors which are listed here with a curve fit operation that we just performed now. So that's stacked up here as 3397 Hertz. And now what we can do is the other modal parameter, which is the mode shape, that we can do by going into this window here. So if I want to just do a simple ODS type analysis, I can pick the particular frequency and hit animate. You can see the mode shape like this. I can hop to the next mode. So given the size of the data set, it just does all the computation quickly and we can see the shapes. Right. This is with the ODS type animation. Now if I With the curve fitting that we just performed, if I want to see the animation, we can do that here. This is with the curve fitting that has been already performed. Another type of curve fitting that is available is LSC fitting, which we have already done with this data set and extracted the modes. Now, over this vibrometer data, if we also have finite element analysis results, we can import that and do a correlation study. But in this particular case, we don't have the finite element analysis data. So what we have seen is, if we have laser vibrometer data acquired using Polytex laser vibrometer hardware, we can import those files, which are either in PVD format or SVD format, and we can do post-processing on that data using the various curve fitting routines that are available in VMAP and extract the modal parameters such as resonant frequencies, damping, and mode shapes. With this, I would like to conclude this demonstration of how to import laser vibrometer data acquired using Polytex laser vibrometer and how to do post-processing using VMAP.